on behalf of Bangalore Chamber of Industry and Commerce, we welcome you all for this exclusive session on improving energy performance, a systemic approach organized under the aegis of Infrastructure, Energy, Environment and Water Expert Committee. We express our sincere thanks to Mr. Venkata Kuppuswamy, who is the General Manager, Key Account Southwest Asia of Lloyd's Register. Thank you very much, sir, for accepting our invitation to address at this exclusive session. This session is organized under the aegis of Infrastructure, Energy, Environment and Water Expert Committee that is chaired by Mr. Ramesh Saligrama, who is Vice President, Projects and Facilities, Bosch India, co-chaired by Ms. Anuradha, GM Power Strategy, Praxair Linde, and Mr. Shivayogi, Manager, External Affairs and CSR, Toyota Kirloskar Auto Parts. And the committee is mentored by Mr. Rajendra Hegde from Toyota Kirloskar Motor. He is the GM of External Affairs, State, CSR, PR and BIA Division. This session is jointly organized with Birdi Industry Association, and we have with us Mr. Murli, who represents Birdi Industry Association. We also welcome the leaders of the expert committee. Thank you very much for joining us for this session, sir. Over to you, Mr. Murli.
Yeah, thanks, Rupa. Before we start the session, I deem it an honor to introduce Mr. G. Venkata Kuppuswamy, our speaker for today's event. Mr. Kuppuswamy has got over 29 years of post-qualification experience in the field of quality, environment, and safety. And he has been assessing conformance and compliance for a wide range of industry sectors that include construction, business, and management. He also gives lots of consultancy in project management in automotive, food, textiles, manufacturing, paper, chemical, metal, cement, electrical, and other diversified industries. He joined Lloyd's Registrars in the year 1999. Currently, he is a key accounts manager for Southeast Asian region, responsible for organizations like SKF, Toyota, L&T, Honeywell, Gartner, Coca-Cola, PepsiCo, etc. And he has assessed and trained organizations in quality, environment, energy, and work safety performance improvements for more than 2 decades. And he is a MTech in metallurgy from National Institute of Technology, Surathkal, Karnataka, Masters in Industrial Chemistry from the Algappa University with distinction, and is a Masters in Business Administration from Madurai Kamaraj University. He also holds a post-diploma in Quality Management from United Kingdom. So with this brief note of Mr. Venkat Kuppuswamy, I heartily welcome him for the joint session of BCIC and BIA. Over to Mr. Venkat Kuppuswamy. Welcome once again. Thank you.
Thank you, Murali. Thank you, Rupa, for giving such a wonderful introduction of myself. And this session, I would like to sincerely thank BCIC for Bangalore Chamber of Industries and Commerce for inviting me for this and having given me a platform to address. It's jointly co-hosted by, I learned that Bangalore Birdi Industrial Association also. The topic for today's discussion is improving energy. Can you all see my screen? My screen is visible? Hello, my screen is visible. Am I audible to you?
Yeah, it's visible.
Right.
Visible.
Thank you. Improving energy performance through a systemic approach. That's what is the topic of today's discussion would be. The content of our discussion, that's what many people will be curious to know. What will be the content of today's discussion would be the need for the management system we start with to build a sustainable, resilient business. That's what it's going to be. What are the key requirements, the current business scenario, and how to look for a specific energy consumption and a route for compliance, how this will enable you to route for compliance, and later to which we'll have a question and answer session. And to tell you in the first instance, I'm not having a voluminous slides. I do not have. I have only about 23 slides I've got. I'll dwell on this each slide to make you understand the more of an interaction, more of I will try to express you to the slides, and later I will give it open to the question and answer session where you can ask as many questions and then we shall try to clarify it. The need for energy management system. What best time we can have other than present? There can be no other better time. Can you mute the microphone? There cannot be a right occasion then to talk about energy at this point in time when we are literally staring at the barrel. I mean to say the crude oil barrel we are staring at. Never in our lifetime we have seen the price rising up to 110 liters petrol 1 liter petrol cost, and a spiraling increase of the coal prices even. Not long time back, a fortnight back, if you all seen the magazines, you would have found out every news magazines carried a threatening news that we have got coal reserves only for 2 days left. That's what was the scenario. And the coal price of it is spiraled up, like in the sense, not one side the fuel price, another side is the coal price, and the import of the coal was also found. We are finding it difficult. And at this point in time, all the power plants which are running based on the coal are partially operating. They're not operating fully. And our reserves and our domestic coal, which we have got, has got a very pathetic, very low calorific value because it has got a high ash content. So it cannot sustain, the power plants cannot be efficient with the domestic coal what we are having as reserves at the moment. So at this point in time, even I would like to mention the National Electric Grid in India has installed capacity of 388 gigawatts. Wonderful. As of 31st August 2021, we are having that much of the capacity we have got. Even our government has told till 2027, we should not have going for any coal-based, any power plant should not be. We are encouraging the renewable power plant. But what is very pathetic and awful is our transmission and distribution is very, infrastructure is very highly pathetic. That's what is the problem. But are we going to talk about it today? No, it doesn't make any sense to talk about this because it doesn't going to yield you anywhere. Like in the sense, we can only debate, we can neither do anything on it, neither we can influence on it, or we can find a solution for it. It's beyond our scope of discussion today. So what's that we will limit ourselves is, like what is that the best we can do and what our contribution towards this would be, and that's what will be the take home for all of us at the moment. See, if you see my right hand side of my slide, there are three out of the pie of the total all India electricity consumption. The pie which signifies the industrial part, the commercial, and the agriculture. These three things, take away about 85% of the electricity what we generate. And the rest of it comes commercials and the miscellaneous and the traction forms the rest of it. Even in the industrial, there are certain industries which guzzle more power, which take away more power, that we will discuss a short while from now. But what is the role of ours towards this energy conservation? So we all know when we are working in an organization, we all know that there is an operation cost associated with that. Every organization, be it a manufacturing, I'll just now concentrate on the manufacturing industry for the time being, and then I'll go for the service sector a few minutes from now. See, the manufacturing industry, the operation cost primarily constitute of A, the salaries and wages, B, the raw material cost, C, the consumables, and the fourth one is with respect to the electricity and the fuel cost. So out of these four, we cannot touch the hygiene factor of salary and wages, we cannot touch. And the B, with respect to the raw material cost, many of the organizations, some of the organizations, the raw material cost alone contributes 50 to 60% or even 70% for that sake. So even metals that like industries like aluminum smelting or iron and steel or whatever that those type of industries are smitten on one side with the price is being fixed by the LME. The LME fixes the price and they cannot negotiate on that. So they cannot do anything on the raw material cost also, little they can do about it. The other one, consumables can be reduced to an extent possible. And the fourth one, which we were talking, that's what is the context of the discussion today, is with respect to reducing the consumption of the fuel and the power what we are using. And that would sizably can reduce. I can sizably is a strong word which I'm using. Even if it can marginally, if you can reduce the cost, that much adds on to the bottom line as a margin. And that is what is the topic of discussion today. And what are the showstoppers or what are the problems which you are facing towards it? One is the basic awareness. I would say awareness is the key for the energy management. How many of us know, like even for that matter, there are many in the service-oriented industries who are making the software development and other things and all. They may think, hey, we are not a paper and pulp manufacturing. We are not a textile industry. We are not any chemical manufacturing industry. We are not a process industry at all. What is that we can contribute? That awareness part of it. If I to tell you something to relate it to you, how it can be seen, a 17-inch of a computer, if you just take it, that size, the power rating of that would range from 65 to 100 watts it could be. And if it is switched on and it is being used, it'll take away 38 watts per hour. And if it's for 365 days, if you just work on it, it'll be around close to 865 kilowatt hour units it may take. That in the kilowatt hour units in a year, a 17-inch of a screen of a computer may take through. So this corresponds to 360 or 365 kg of carbon dioxide emission. And that energy is equivalent to you drive a car, any average car, up to 1,360 kilometers. So this is what is the energy part of it with a single system, what you are holding and what is that you are looking at and you are working on. Look about how much it can contribute to the environment in terms of the power consumption it might be. If it is several batteries of laptops and a battery. Laptop is much higher even for that matter. I talked about a desktop. If you take a laptop, which is, I think, it should around 200 watts is the power rating it would be, consumes much more than what I've told. What coupled with awareness, the competency is another core thing, I would say. Competency is nothing but normally competency is constitutes three important factors: knowledge, training, and the experience. These all three together form competency. So knowledge alone is not enough. The people need to know and apply in the form of an experience is required. And then they try to apply it towards energy conservation. So competency and awareness together form an important element. I was mentioning it to you. The another one is the effective communication. How many of us know, like in the sense, if we can, like the organization they are working on, the power bills they would have seen. And even if they have seen the power bills, how many of you then know how much is the contract demand, what is the connected load? And even if they know it, the time of day of the power and what is the peak load and what is the off-peak load and what is the power tariff at the peak and off-peak load, the people who not have gone in depth of it at all. Like, in the sense, that effective communication within the team members and within their operations also, like, is an effective cog of the management's energy management part of it. Because in this energy management system, everyone have to have their own role. They've got to play a vital role towards minimizing the consumption part of it. So effective communication forms a dominant factor as far as energy is concerned. Another one is the data analysis. We always say that if anything cannot be measured, cannot be analyzed. If anything cannot be analyzed, you cannot improve it. This is the basic fundamental slogan or an expression in any quality, be it a quality environment or any other topics of discussion. It would be basically a quality discussion. It is things has to be measured to be analyzed for improvement. So data analysis, like you have seen many organizations have got mines of data, like they've got so much of a data accumulated, but it would all gone to the vertical files, or they would not have given a thought for its analysis towards improvement. Analysis of that data is important. And the last 2 points which I would like to talk to you is with respect to that achieve net zero. This is a topic which you have been hearing for at least for a decade or so now, very constantly. And the latest part our Prime Minister had expressed in the last week of the news magazine, if you are seeing, that he had even committed in the COP26 that we will be achieving a net zero by 2070. That's a commitment. What is the CEO's, this COP26? There are various goals they have been asked, they have been exchanging, but one of the primary one, the first goal, which they even talked about in 2015, the Paris Convention also. During that time, they were telling that the net zero, that carbon emission should be brought down by zero by mid of this century. That's point number one. Coupled with the temperature should not be rising more than 1.5 degrees centigrade. This is what they were told. If it goes up to 2 degrees centigrade, then there will be a rise in the sea level of 0.66 meters of increase in the sea level, and the entire world coastal area will have a problem of its land erosion, plus the salinity of the water, the potability of the water will get, and there are many other impacts also would play a role. And that's what they have been talking about, how the temperature need up. This was in the Paris Convention itself, it was talked, but it was re-emphasized at this point in time, should be less than 1.5 degrees. Good enough. There are many other topics they were discussing about how the people have to finance the developing nations, also how there should be a common time frame need have to be established. What is the carbon market? All these things are all a different subject. Let's not talk about it. But talking about this net zero, again, it was expressed very clearly, though it was talked in the Paris Convention even. This time they were telling every nation has to come out with NDCs. NDCs means what? Nationally determined contributions. Like, they have to contribute. It's not that just they commit and then come out. They have to contribute, or they have to commit themselves, this is what it is, and that has to be reviewed. And they even had concluded this point in time that in 2030 they should exceed the NDCs what they have committed. That means the nationally determined what we call contribution, what they are making, that they should even exceed it. If that is to be exceeded, the work has to commence. And even 2016, if I remember right, Australia had come out with a plan of NDC. They were told that they will be reducing 28% emission of 2015 baseline as a baseline. They will be reducing it. If such things happen, if every nations come out with such a contribution which they need to make, the entire business dynamics would change. If you are importing any components from other countries, or if you are exporting to the other countries, the demand from that country will be like, what is the carbon footprints of this and how much it is? So the first step towards all these things is towards the energy management. Like you have to know fundamentally that this what is the energy which we are consuming, and towards this how much I can minimize to the extent possible, and thereby I'll go towards a net zero, which is a very big topic of its own, need to be discussed separately. But yet the fundamental points I can really touch upon to you if you want to. So that is what is the one which we need to understand about to achieve net zero. This is the first step which you need to take to analyze and then find the carbon footprints. I'm not going to talk about scope 1 emission, scope 2 emission and all. There is a little bit of a diversion from what we are going to discuss now. But to know from gate to gate, what is that, the energy, what is being spent in any form of it, that you need to understand, collect the data and analyze it. That's what it is. And that is towards the first step. This is the one which you're going to do. And of course, the last one is to demonstrate compliance. Well, I mean, the PAT scheme is there for quite a long time, and PAT cycle 6 has already had come. The people have identified designated consumers of certain numbers. They have identified, it started with 6 numbers of textiles and what we call the cement sectors, paper and pulp, pharmaceuticals, chemicals. These are the sectors which they have identified. What is the need for the energy management? Now, I was talking about the different sectors, right or not? So we will talk about digitalization is now very widely, it's been been practiced, and we are now looking towards that also for that sake. And you ought to know that it also guzzles to an extent of 10% of the world electricity is consumed through by means of our computers, by means of data centers and network. Of these 10%, the 30 to 35% by the terminal equipment alone consumes it. That's what it is. Textile has got a very pathetic record, very poor record they've got. The poor record in the sense, the spinning consumes more than 35 to 40% of energy, spinning, and weaving, of course, slightly lesser, and finishing guzzles more than 40% of energy, where the steam generators are poorly performing. The steam generators, the steam is used for washing, bleaching, dyeing, and all those factors which being used, it uses more power, and the efficiency of this steam generators, is less than 50% for various other reasons. So textile sector is placed that way. Chemicals. Of the entire pie, what you saw in the industrial sector, chlorine ranks the topmost of it. That chemicals, the chemical organization which produce chemicals, they are the topmost. They are sitting on the top of the list because they consume more energy. Followed by nitrogen and oxygen. Not long time before, we were running helter and skelter for oxygen, for want of oxygen, and also all the benzene and its derivatives, benzene, toluene. I'm sorry. I'm sorry. Am I audible to you all?
Those who are not speaking to put on mute. Sorry, Mr. Gurumurthy, I think you can go ahead. I think somebody had switched on the microphone.
Viewers request, please mute your mics. Thank you.
Thank you. Thank you. So followed by the chemicals like benzene, toluenes, and propylenes and polypropylenes and all, they also guzzle more power, and because their feedstock is petroleum based. And when this feedstock is petroleum based, they are closely located to refineries also. And that's the reason the chemical sector has been ranking tall in terms of energy consumption, which is very high. And followed by the food industry. I will not say it's following. Food industry also has guzzled more power in terms of the processing cost and the logistics cost of it. That consumes more energy for that sake. And here I would like to introduce, because the people who are now gathered here from various industrial sector, maybe I just wanted to tell about how a product mix has got an influence towards the power consumption. Say, for example, food is a normally everybody likes it, and that example can be talked about. I can share it how a product mix has got. See, if you take a chips for that matter, like this is the people who are manufacturing chips in an industrial scenario, they have to dehydrate the potato. The potato is a common raw material, and they have to dehydrate the potato slices up to 2 degrees centigrade. I mean, what about 2% of moisture content. That is, it's to be dry to that, and then they have to deep fry it or whatsoever it is to minimize, to get that for what you call the mouth feel and the other factors of olfactory senses which they need to gain that advantage. That's what is the processing part of it would be there as far as the chips is concerned. But the same raw material for a finger chips, the organization, if it makes, even if it is the moisture content is 15% or 20%, it will not have any impact at all. But if you just see the carbon footprints of what or the energy consumption of the chips, what it's been made, and what the finger chips being taken for the same organization, the power consumption or the carbon footprint for these two products will be totally different. So in an organization, when you collect the data and the information, you should also look at what product combination is also yielding or it contributes to the power consumption part of it. This just to know about the product mix. Talking about the cement again, the mines where the limestone exactly in the mines and other things, where in the summertime the power consumption will be a little different than in the rainy seasons, because during the rainy time the mines are getting flooded with water and you have to pump out the water and take the limestone. The limestone has got highly moisture, and then drying it and then taking it. So depending on the season, the consumption levels also varies. In the cement industry, if you just talk about it, I remember that it takes more than 280 kgs per ton of coal. That's 280 kgs of coal per ton of cement. If it's a dry cement process, if it's a wet cement process, it goes up to 480 kgs of coal per ton of cement. So you just see that how the energy getting guzzled, I mean taken up by these industries, and that's what it is. Every industry are working towards minimizing it. Paper and pulp, even the engineering industry. Some people say, hey, look here, we are not belonging to any of these batteries of organizations, what you talked about. We are having a CNC machines, and in the CNC machines, we are doing the job, and where is the power consumption is. Even there are papers, published papers. I've got my own experience also to let you know. I'll just tell you, for example, like if you're turning a cylindrical bar for that sake, and if it is being machined, and we'll take the tool wear, the tool shank wear up to 0.08 as a criteria if you just take it, and at a speed, at a feed and a depth of cut, they were taken, the studies have shown also, if you take a 5 pieces and then measure the wear of the tool and then extrapolate it further, so that different RPMs and different rate of feed and depth of cut can be made, and then they have shown even that it still has got an impact. The variables being the speed and the depth of cut are the variables which can minimize the energy consumption also if being operated in a way it is. So, and what are the, if you just look at the right hand side of my slide, you've got a force field analysis. This is one of a tool normally people use to find out within the organization which has got a larger magnitude and higher magnitude, lower magnitude, medium and less, in terms of could not achieve both the positive and the negative forces. They need to, this is one of the tool which they do practice some of the organizations. What makes or what are the positive points to reduce the energy consumption? If you look at it, high price of energy is a positive factor. Yes, high price of energy, I've been kicked actually, so I have to now go for and try to reduce it. So that is a positive factor. And the energy efficiency technologies are available with me. Like I've got the source, I can change the source of energy because I've got the technology. I will go for the wind energy part of it. I can invest on it. So the source use and consumption, I'll talk about it later. So they talk about the efficiency of in terms of technology, what they've got. Sorry. And they've got about incentive for the power factor. Many organizations give an incentive for power factor. Power factor is a very vital one. If you just look at the 0.85 to 0.95 or 0.96, if you just look into it, the data says you'll be saving about 21.1% of the peak load of that much of a saving that it corresponds to. So power factor is a thing which is a positive one with incentives what being given, like even the state electricity board gives an incentive towards that. And then the top management commitment to energy. This is very important. That's the reason when this discussion started, I was telling the top management should be available. Many a times the top management are very much focused on the customer requirements, customer satisfaction, the bottom line, the top lines, And they also look for the quality of the products of the one, but never, I'm not telling totally, I mean to say about 30% to 40% of the organization, the importance towards the energy is very less. It's not given to that thrust. But in this case, positive, if you talk about those organizations which have got a commitment, it has been positive. That's what is, which will enable them. And energy is a relatively high component in production. Say, for that matter, even if they do not like it, I was talking about the cement, pulp, paper and pulp industries and these chemical industries. They have to go for it because the PAT and the government schemes and the government trust has been so high. So that is also, or if the energy consumption is naturally high, and if they find if it's more than 10% of their total operational cost, then naturally they go for it. And those are the positive factors. The absence of a corporate energy policy. That is one thing. Like the policy, we have got policy for quality, policy for environment, all those things is there, but rarely we find policy on energy front. So the top management should commit that they are there available to reduce, to improve the energy performance, and they are there to support the energy saving, or what you call technology, or the energy saving what you call investments in terms of machineries they will go for, and they will even see that the communication is being spread from top line to down the line. After all, a simple law of physics is it flows from the water flows from a higher potential to the lower potential. So if it has to flow, the top management commitment is essential, and they have to demonstrate it. So in that way, that is very important. And rest of it, you can see by yourself the lack of what you call people throughout the organization. That's what it is. Insufficient skills because the people are not having enough skill to understand where they are losing energy, and competing corporate priorities. Sometimes the priorities are misplaced, not towards energy, it is towards something else, which I was mentioning it to you a while back. So insufficient financial, I've not budgeted for this year, I don't have the money to invest in the technology. These are some of the factors, are the negative factors, which pull down towards reducing the energy part of it. I always relate it to the triple P, that is the energy and the triple bottom line of 3 Ps: profit, people, and the planet. In terms of profit, you all know, since we have discussed for the last 10-15 minutes, it talks about decreases in the operation cost. Operation cost can be minimized. Your penalties towards the energy use can be minimized. The taxation appropriately can be there, and towards the planet, you are decreasing the carbon footprints of manufacturing, the depletion of natural resources, you will be passionate towards it, and with the respect to the people, you become socially responsible and socially committed that yes, I am here to save the environment and to minimize my carbon footprints of the people. So that gives a social belongingness also. So that is what is the people factor of it. Okay, let's see about what builds a sustainable and a resilient business. This is what it is. Yes, I've done it. So many people just up and then say, yes, I've reduced the specific power consumption to this much. But that be a flashpoint. It will not be a permanent, repetitive, or it cannot be reproduced. For that financial year, they may say, but how to make it sustainable? How it can be made? A time and again, you can have it for every financial year, the specific power consumption, you can reduce it and demonstrate it. For any business, see, I'm not here trying to say you have to follow ISO 50001 as a standard. See, when I talk about something, I have to talk about something which is an established standard. So in this discussion, after about 15-20 minutes of a discussion, I'm just telling you this entire, from now on, there has to be leaning towards some standard. And I've taken 50,001 standard as one of the element to discuss, but leave about that 50,001 standard for the time being. Let us apply a common sense and then look into it. For any organizations to thrive, they should have the context of the organization. What is the scope in which what they are working for, to whom they are accountable for, and what are the external issues and the internal issues threatening the organization, to see that they still maintain the margins in their bottom line and they try to earn as much of a top line as possible. That's what it is. All the stakeholders pertaining to the organization who have invested there, this was the basic thing they will be expecting from them. So, but whatever may be the external issues and the internal issues, I cannot go back to the investors and then say it's due to the pandemic, it's due to the petrol cost and the fuel cost has gone high, and I'm not able to show the margins. It will be pathetic. It will not be able to, the people who are responsible for it will be often put to lot many questions, which they cannot tolerate also. So the context is very important to understand what are the external issues and the internal issues which they are facing. Taxation is a problem, fuel rise, coal rise, everything, even the energy cost which the state electricity board rises, these are all the external issues that the organization need out to face, and still they need out to take care of the interested parties here. Interested parties could be the people who are working along with them, the board of directors, the investors, whomsoever it is. And for this to happen, as I was telling you, the leaders stay committed. The leaders are the people who derive, who deploy the energy policy and make people understand. As I was mentioning you, they should be able to communicate it down the line, and they should be committed to say, I'm staying here to buy any energy saving devices at whatever cost it may be for that matter. And they should even demonstrate that they are complying with the legal requirements also. So these are some of the things which the leadership team need have to demonstrate at that point in time to show their passionate and their involvement towards energy conservation part of it. And of course, the risk and opportunity. Risk is a combination of two factors. I always say risk is nothing but an outcome of severity and occurrence. The severity of organization going red for due to its operational cost very high, or its inventories being very high, what a reason for that matter is. So how I'm going to minimize that occurrence by looking at the opportunities and then making it as a operational control programs and then go about it. And of course, competence, we talked about it earlier, and the operational planning and control towards that opportunities what you have identified need out to be worked on. Slides are not moving. I do not know why, certainly. Yeah, yes. So this we will spend about 2 to 3 minutes, 2 minutes in this slide, which forms the fundamental of how the specific energy consumption, how you have to start about, because after this session is over, when people walk out of the portals, they may think, hey, what is that? I mean, this guy has talked about all this while, and what is that I might take home as? That's what will be the question asked. So this slide, we will deal it for a minute or so. So for more than a minute, I have to express you where we have to start as an organization. See, energy reviews that you need to start. I'm working inside my organization. You could be a foundry, could be a machine shop, could be data centers, could be anything. Like, look at which are all the processes I've got. Like, those processes can be input of a raw materials to the customer specific requirements, which is getting inside, until the delivery process. What are all the processes are there? And these processes, what are the energy consumption for every process does it happen? So, I mean, you can have a metering or a sub-metering will already be there. So the data collection should start. And after collecting the data, you should identify which are the significant energy use in that process. So taking that significant energy use, you have to identify which variable contributes to that significant energy. I'll tell some example. As a few minutes back, I told you, humidity or the water content in the potato chips is one of the variables, is a dominant variable which guzzles the energy part of it. That's what we saw. So what are the significant variables? If you just take a foundry, if you just take it, raw material melting, the melting consumes more amount of an energy. So idling time of my liquid metal in the furnace, how I can minimize it, what are the charge contents, the sequence that I need to add, and what is the frequency of increase I have to do it in the induction furnace. That is the type of variables which you need to look in and then say how to minimize it. As I was telling in the machine shop, like the feed and speed and depth of cut, if that is the significant variable which contributes, which guzzles more power as far as the machining operation is concerned, what is that I have to look into it. So you have found the significant energy use, and for that significant energy use, identify the variables, the significant variables which contribute to that consumption. That is a point number one to begin with. And when you just collect this data, you should look at the past energy consumption of the same process, the current energy consumption, what it is, and what will be the future of it, because you may be augmenting the capacity. You may be looking at many other things also. So look at the past, present, and future, and then you have to establish the third point of a baseline. Before coming on to the baseline, I will touch about the energy performance indicators. ENPI is nothing but energy performance indicators. This is very vital. Even about day before yesterday and yesterday, I was talking to an organization when they were telling that this is what they are going to reduce of a power. These energy performance indicators are important. How you say that I've scored 100 marks. If I come back home and then say I've scored 100 marks, then the people will ask, out of how much you have scored 100 marks? Out of 300, I've scored 100 marks is pathetic. But the people who cannot understand, they say, oh God, you have scored 100 marks. Like, so they may think different. So energy performance indicators form in that way. What is that? Like in terms of, it would say that if it's a steel industry, my kilowatt hour consumption per ton of a liquid metal or per ton of the metal which I have produced. So per ton. It could be per kilocalories also for that matter. It could be various. The denomination has to be very clear. per ton of, or I mean, what call it, or you can otherwise say, if I'm not able to say in terms of liters or in terms of a ton, in terms of whatever the product output what you are giving, you have to measure that against per ton, whatever it is. For that matter, if you can look into different, if you're not able to reach anything, you can even say about 10 million. If I'm invoicing 10, every 10 million of my invoice, what is the power consumption is and where you want to reduce. So that performance indicators are very vital, are very important. I was telling a recent example of an yesterday when I was in an organization, they were talking per batch consumption is 385 kilowatt per batch consumption. That will lead no way. They are making aluminum powders for that matter. What is that? What we call per batch? Per batch makes no sense at all. Like per batch will be 380 kgs. It could be 480 kgs also, whatever it is. So per batch need out to be specified means that you have to look at per kg or per ton. That's what is to be relevantly it's to be established. I've seen many organizations do follow the same way, that they need to look at what is the base value, what they are setting as a performance indicator, very important. What is the baseline? If I have to improve, then I have to compare with something else. I have to set a baseline for myself. And you cannot set a baseline for a different organization because it's totally different and it's totally nonsensical also to compare with some other organization. Of course, there's a benchmark and other things we can talk about, hi-fi things later, but let us talk about the basics. Like, okay, I am performing with the same set of tools, same set of people, with the same infrastructure, with the same management, with the same, everything is the same. But why this time I'm consuming more? Why this particular period I consume more? For that to compare, you should have a baseline. The baseline you can set for yourself, anything for that sake. You can even lean back and then say, in 2015, this is what the product mix was this, and there was no pandemic and there is no partial shift running, and also and the customer demand was this. So that time we consumed this much of an power per kilowatt hour of per every ton of my output which I have done. So I will take that as a baseline, and for this year I will try to be lesser than that. And that difference is what is being represented here as the target what you take and then work on, and then you can compare it. And then you say in the next financial year, it will be much lesser than this. So that this to be communicated to the people in the shop floor, so the people know, for that matter, I'm working for this year this much, and for the next financial year I have to still more travel to that much of a distance, and that's what I contribute, and this is what is a significant energy use I've got, and for those significant use I know what is the significant variables which contributes to it, and I have to attend on to it by means of an operation, good operation controls. And that is what is the one. And when you draw the baseline, it's very easily set. But when you just look back and dig the records and then look for it, you may find it quite difficult to set a baseline. For that matter, you should look into normalization of that. Normalization of the data is very important. Like you cannot take 2020 for all bad reasons. I mean, what call, there were many shutdown and the lockdowns did happen, and even when it was open with the partial people and the partial utilization of the resources you had, so that cannot be derived as a baseline for any this one. But you know, for that sake, that normalization of the data can be done with respect to the number of shifts it was run, the number of hours it has been reduced to, all those things, and the weather conditions and other things and all. You can take it and then you can normalize the data, and then you can establish a baseline and then go about. And of course, the last one is with respect to the roles and responsibilities need have to be defined. So without the roles and responsibilities defined, it becomes difficult. Sorry, what do we need have to know? To build a sustainable, resilient business, again, we talked about the top management commitment, and followed by you have to know about the assess the performance, what is the correct performance, and then you have to set goals for yourself. And with the setting the goals, you have to create action plans to achieve those. Setting goals alone is not important. I used to keep telling at my home also, like, I want to do this much of a one. It starts with domestic to in the industrial professional front also. I have to achieve this much of a grade. Doesn't mean that you can just jump in and then go and write for the examination and then score. I have to set my goals. I have to work for it. And to work towards it, I have to create an action plan for it. And then when I create an action plan, I go and implement the action plan. And this is nothing but a plan, do, check, act cycle only, nothing else, nothing great about it. So implement those action plans. And then so in the implementing these action plans, in this case, those significant variables which you already had identified, you have to work on it and then go about achieve the results. The key requirements are this, again, a repetition of a few, so I'll just go through quick so that to save much of our time also. This is nothing but a plan to check act. I was mentioning the context of the organization. We already talked about interested parties, the scope and other things, entire thing which you talked about. This is what is very important. Energy management team. I would like to mention the top management should form an energy management team. How many organizations have got an energy management team? There are a few organizations whom I visited, like I need not have to mention, and I don't want to drop the names here, but big organizations have got their energy cell for that sake, and they do their own energy audits. They do because that is not out of passion also, or maybe out of passion. I'm not denying that, but out of compulsions they need out to do that even. But a medium-sized industry, though it is not a compulsion, but for your own benefit's sake, you can form a cross-functional team involving the utility people, the quality and the production guys all together. They can form a team and they can discuss about the energy consumption and the energy conservation aspect also quite frequently as whenever they are having the daily production meeting. I know some good, for that matter, if I can say, hotels. If you walk through good hotels, I mean to talk about any 5-star and 7-star, the general manager will be having a daily morning meeting and he'll be talking about energy only in that case. I mean, if you have seen that, unlike other organizations where you also will talk about energy, I'm not denying that. I'm not taking the credit out of any of the organization who have participated here, but that will not be the first point. That will be the 7th or 8th or 10th point. You'll be discussing about that day's dispatch, that day's quality issues, what you had, the customer complaints you had. That's what the priority takes place. But in the case of the hotel which I'm talking about, they even talk about how much of LPG consumption per pax, how much of food consumption per pax. That's what they calculated, and then that's what they discuss it also for that matter. And per pax is nothing but the performance, energy performance indicators. Like this much of an LPG, this many grams of LPG consumed per pax of people. That's what it is. And then so the energy management team is very important. You should have a cross-functional team. Risks and opportunities, we discussed about it. Energy reviews, we have talked about. Significant SEUs are nothing but significant energy use, energy performance indicators, set energy baselines. We have spent quite time on that, good time on that. Action plans need out to be drawn. Operational controls need out to be established. Communication, design and procurement, we didn't talk about it. Design and procurement is very important. Like any project we start with, I always keep saying this. The design of a project, you want a prime mover. What is that? The rubber industry means, okay, for Banbury mixture, for rubber mixture, like, okay, good, and how much it is? Okay, 150 kilowatt motor we required, sir. But why 150 kilowatt motor is required? Now it is only the sizing of that would be required, will be only 100 kilowatts. Why 150 kilowatts? No, after 3 years from now, we'll be augmenting their capacity. That time we cannot run for the prime mover, but that is a very ill-advised part of it. And during that, till you augment your capacity, till you ramp up your capacity, that 50 kilowatt or 10 kilowatt even for that matter, that is a recurrence expenses which adds on to your electricity bill. And when you find that it's consuming more, you go for a variable frequency drive and you invest in many things. I used to hear a saying like, why to take something undigestible and then take a digestive tablet to digest it also. That is a very immature way of thinking about. So designing of the project equipment at the design stage itself before procurement is very vital to talk about. Yes, it requires this much of, because the people, the consultants, if they want only a 10 HP motor or a 10 kilowatt motor only required, the consultant may say, okay, no, already he would have factored about a certain amount of a safety factor in it. No, the consultants, I'm not derating, I'm just saying the people who impart the knowledge part of it, they say, no, let it be about another 5% because the initial torque will be high, the temperature will rise about, and there will be inefficiency of the motors will be there for that matter. So let us go for a higher rating further, because without knowing, so that design is very important before procuring, and then go for it. So at every new, whether you're doing modification of an existing product or a new project which you are going, spend time on the design part of your equipment, what you are procuring, and then make a wise judgment. Then the implementation part of it, the action plans, we have already seen that about, and the operation controls for those significant variables. The competency of the people, again, it comes to design of procurement, we already talked about. And the non-conformance is acting on the non-conformity. That's what is plan, do, check, act. If I find, yes, in the project wise, if I study, yes, this I had studied the return of investment of this equipment which I have procured up to about 14 months or 16 months, and you see that it has not yielded that much amount of a yield is not there, that much of amount of saving is not there, and I could find this 14 months has crept up to 20 months. That's also non-conformance. My judgmental skill has been wrong. My calculations has been wrong. So what is that I need up to do? And that is what for the next future projects or for the existing ongoing projects, what I need to look into. And that becomes, you may take a corrective course, a corrective action in place, you may put it across, and that becomes non-conformance management. And when you just work on it on a continuous way, then the continual improvement of the process sets in. Your energy, attitude towards energy saving will be creeping very high. So I was been talking about putting everything together. Here's the leadership, the continual improvement part of it. They have to commit, and all the plan, do, check, act forms. What do you call? The leader. This slide is to indicate that leaders are the nucleus for this entire energy conservation part of it, and they have to show the commitment. We shall spend about 2 minutes on this slide. That makes a lot of sense. Usually we heard about hierarchy as far as the occupational health and safety concerned. In fact, the people who are there, occupational health and safety specialists, they may say that elimination, substitution, engineering changes, and then what do you call administrative controls, and the last line of defense as PP. That's what they say as the hierarchy of control. Never talked about in the energy concept of prevention, reduction, and reuse and disposal. These are some of the things which you need to look in. The prevention part in this case is like actually it's a low hanging fruits. It's always a low hanging fruits. If you can see, if they've got 4 or 5 what do you call material handling equipment, they've got tried what do you call material handling, if we could talk trucks or the forklifts or whatever they've got for that matter, they would not have analyzed for out of these 4 trucks of the 4 what do you call material handling equipment, one equipment will be guzzling per hour, because those forklifts operate in terms of the fuel consumption per hour. One will consume about 20 liters per hour, and the other one will be consuming only about 15 liters per hour. So it's not that. So you can prevent that particular forklift from using it, because it's need not have to be used. You can manage it with the other forklifts within the organization. Sometimes they will have 2 boilers, and on one boiler will be pathetically performing with a heat rate, whatever it is like. But the other one will have an efficiency of 85%. The other will have a efficiency of 79 or 80%. Maximize the utilization of the boiler, which gives a higher efficiency. So prevention, this is what is preventing from use, the one which is having lesser performance. Like even in the field of even the game of a cricket also, those days they used to say, if this fellow is a poor fielder, put him in a corner so that he is not, but that those concepts have gone nowadays. I'm just trying to equate it the way I can give us analogy for you to understand. So prevention is nothing but an equipment in your batteries of equipments you've got, one which has got very less performance. You operate it at a lesser frequency or a lesser time of loading it. The another one is with respect to reduction. Reduction, I always keep saying this quite often. If I have got, even in this pandemic times, if my shift starts at 8 o'clock and ends at 5 o'clock, but for that matter, the partial shift, I'm having raw material problems and other things, like even the pandemic times also, like instead of starting at 8 o'clock, the furnace for that sake, or the machining operations for that sake, and so that the idle hours can be minimized, you can group it between starting operating between 10 o'clock to 4 o'clock at a stretch, so that there is no idle time. So reduction in operations for that matter, that will also lead to a lesser consumption. Even heat treatment process, if you just look at the heat treatment process, they used to punch the material so that the cycle time of annealing or a normalizing or whatever it is, they'll be doing it at a particular short interval time, so that they load the furnace to a good extent and then make use of it. So reduction can be thought in that way. And then reuse. Reuse is nothing but for that matter, if in a boiler stack emission, the stack emission, normally it is recommended 170 degrees is better, like in the sense 140 degrees above, 140 up to 140 degrees is okay, because the sulfurization of the stack will take place, and the stack may crumble. So some people operate at 210 degrees also. That means the excess fuel is utilized and the combustion is high, and the heat has been unutilized heat is venting out, you are venting it out through the stack. that can be reused. That's what the waste heat recovery can be made, and that can be used for what you call feed water of the boiler can be improved for. If it is the feed water boiler, if it is 90 degrees centigrade, you can increase up to the boiler efficiency improves even. So how that waste heat recovery in various forms, how it can be reused, how it can be brought back to your system. Condensate water, they want to bring it back to the system. So likewise, you can think about the opportunities where you have got to reduce it. And then, of course, disposal is a topic where I would say many organizations have got the motor winding policy also. They say the motor, when it is getting burnt of this much of HP and above, there is no point for me to rewind it because it is not going to be efficient at all. The core winding losses and other things are going to be, core losses are going to be very high, so they will not take it. So they try to dispose of such rated equipment, what you call, when it fails. So you have to have such policy also. And this one is nothing but, I'll just magnify it if you cannot see for the sake of betterment of view, for better viewability. Here it starts with measure the usage. This is a simple plan, do, check, act diagram, but in a different way for you to understand very effectively. Measure, we have talked about measure the usage of and identify the key consuming part in your process. Analyze the process and then against the energy reduction hierarchy. So if you have found something which is highly utilized, the process is being used, look at the hierarchy. Can it be prevented? Can it be reduced? Can it be reused? Whatever it is that you have to put it in the hierarchy, and then analyze the opportunities against what we call we saw about the triple bottom line. Sometime back we saw 3 P's: people, planet, and profit. You put it in that and then assess it and then bring about a project. And after bringing about a project, communicate with the people, measure the usage and confirm its strategy. That's what it is. So this cycle goes on for that matter, and that's what which we need to look in. Again, it is not moving. As a route to compliance, I'm not going to talk about in much depth, only a few slides are only left. I'll just leave it to the open house for them to ask questions. As a route, this will certainly lead to a form of compliance. What is the compliance part? In the European Union member states, they've got, this is the scheme to 2012-27 EU. That's what they've got. They've got regular energy audits need out to be done. Even our state board also, or state electricity board also, or the state government insist on it, like to have a energy efficiency equipments. You need to have the cost savings need out to be shown. The carbon reduction need out to be demonstrated. We were talking about the national determined contribution. Also, we talked about NDCs. We talked about in the beginning. So it will all pave way for that, towards that. And then entire energy usage by an organization, that be it the buildings or the transports or the industrial or commercial process, whatever is the energy usage by an organization can be. So you may have to submit it also. Even in the PAT scheme, you need to submit it. You have to show this much amount of an energy you are going to save. I mean, you are going to reduce for that matter. And that amount, beyond that, if you have saved, then you can even get the certification also. CERs are given, and then that can be taken and you can display it also for your benefit that you are very compliant. So it can be through ISO 50001 route, or it could be energy audit routes, or it could be a green assessments what you can do about. And you can even display your energy certificates, as I was mentioning it to you. We always believe in this. We always believe in when you do an energy audit, you look at the people, you look at the system and process instead of equipment directly. Because in order to get a sustainable saving with least investment, and that can be repeated and reproduced, if that is the case, you should see the people, process, and the system. The process is a vital area people do often neglect. The process I was mentioning you, the significant variables in the process, if you attend on to that, you will be getting a good amount of a saving, a sustainable savings you got. To tell you something, as I was mentioning you, the feed and depth of cut, I will tell the latest experience also. Organization, I don't know, many of you would have been from automotive industries also who are participating. The automotive people, they do a lot of stress because the IATF standards and other things which they are working towards and they are getting certified, they insist on the process validation. Towards process validation, they do, if I have to keep the temperature between this range, between, I mean to say 650 to 700 degrees centigrade, if they have to keep it for tempering or whatever it is, or for annealing process, they keep it at 700 degrees C and then say like, no sir, it cannot be reduced. But why do you keep the broad range of it? And why do you validate? And the validation part, keeping energy in mind, have you validated it? Answer is no. They would not have given trust, or they would not have given importance for a process validation with a energy consumption in mind. So those things, if you look into it, those are the low-hanging fruits which will yield you better than looking at the utilities and networks and the equipment. Because the people start with the equipment. They say you buy this equipment, you buy this variable frequency drive, you put it there, and you find it. When you do all those things, you may have some other repercussions or some other problem elsewhere in terms of harmonic distortions happening elsewhere also. But okay, those are some of the things which cannot be avoided. But you need to know how you have to go about as far as the energy saving is concerned. This always I keep saying, this is the entire gamut of activities of an organization where all the power getting consumed, for that matter in the water treatment plant, the automatic getting compressed air, temperature control, electric power purchasing, desalination sewage. And this, if you just see the doors and shutters also, the logistics, everywhere the energy is consumed, for that matter. You can never, and all these things, if you look into it, there is enormous amount of saving potential does exist, provided you have got a mind to look into it and a passion towards identifying it. That's what is essential. So I'm coming almost close to last one. So we believe we help business to negotiate a changing risk landscape and look towards a more sustainable future. Working, this is what our mission statement is. Working with us will provide your organization with the support it needs to manage risks and stay at the top of the market. We support our clients in the present and prepare them for future success by using a sharp understanding and social, environmental, technological, and commercial changes to work towards a safer, cleaner, and more sustainable future. Gentlemen, this is what we have covered, ladies and gentlemen. This is what we have covered for the day. You can recap what are the topics. If you have missed any, you can see that. And I leave it to the team to ask any questions if you've got. Rupa, if you've got any questions being posed, I can look into it.
Thanks, Venkat, for the detailed explanation. Very clear and lucid. I now request viewers to unmute or raise their hands or even pose their questions in chat box, which will be read out, and Mr. Venkat will be kind enough to answer those. Viewers, you can pose your questions unmuting, or you can raise your hand.
I will not be able to see the questions, Murali, because I'm in a presentation mode. So
yeah, I will read it out. We'll read it out. Mr. Shino Verghese has got a question. He's raised his hand. Can you please unmute Rupa, Mr. Verghese?
Yes, hello. Hi, Kupaswamy-san. It's nice to talk to you again. This is Shainu from TCAP, Toyota Kirloskar Auto Parts.
okay.
And I'm always on the receiving end. I'm the auditee always, and you're the auditor. It's nice to talk to you, and it was nice attending this session throughout. So even though this entire program or the webinar was titled Improving Energy Performance, one other thing I was just wondering was going forward. I mean, the scope that we have in terms of improvement, say it might lie in terms of, say, a 30% improvement or 20% improvement, depending on how inefficient a particular organization or an industry might be. But no matter how hard we try, I guess the best that we can probably reduce or do is that 30% or 20%. So there is also this other, I would say, strategy that is coming up parallelly. I was just wondering your thoughts on it. CCS, that is carbon capture and storage. So that's the high carbon emitting or emitting plants to capture the emissions or the CO2 that comes out and store it permanently, transport it elsewhere, store it permanently somewhere deep down. And finally, that gets converted into a more natural form, like how we have fuel now deep down. So something like this. Do you think it should be mandated for heavy emission industries, and that would yield a much better return on the amount of time and effort that is spent? And definitely this improving energy performance is also important because the mindset comes only through this kind of daily continual improvement. It doesn't come other. I mean, there is no free meal. You cannot just pay money and reduce it. You still have to use your own brains and work on it. So that I definitely agree with it. But going forward, do you think we should go for something more that can give us a better return?
That's true. That's true. See, your question is valid. I'm not say that it's a very. I'm sorry if I'm using a wrong word for a choice of a right word. Don't get me wrong. It's a very wishful thought. It's a very hi-fi thought at the moment when we are not able to. That's the reason we are going to take the elephant slice by slice. To begin with, that's what we are in the PAT 6 cycle, which I was talking about. The energy guzzling units been identified as a designated consumers, since your question also pertains to that, are high energy consuming people. That's what you mentioned it also. Like they've already been given a mandate towards how much of energy they need to reduce year after year, and they have been under the strict surveillances also. Now, talking about your technology of you just taking the one and then deep burial of it and then collecting the CO2 emission part of it, it's going to have a lot of investment, like actually where the people will not be able to do it in the right away, at least for another a decade or so. Maybe you are the one which you are expressing, which is quite right and quite valid also in every sense, that it requires a little bit of a very high-fi investment, where that's the reason when you look at the first patch cycle, when they began with, they looked at only the process controls they were wishing to improve upon and then go about. Now at the called sixth cycle, which I was mentioning, the requirements are very stringent. Now they've gone up to even a building with 100 kilowatt or 120 kVA also should fall in the segment of they should have the energy audit, they should show a reduction. To that extent we have come. So to that extent, why only the chemical industries or textile or pharmaceutical or for that matter cement and paper and pulp? No, even the organization which has got a contract demand or the connected load up to 100 kilowatt also for that matter, they need how to follow it. So slowly we are creeping in. We cannot just push it right away at one single stroke. We cannot do that. So the government is taking efforts towards it. But the point what you're telling is quite feasible and it's well taken. But will it be done? I don't. Now the people have started using the IoT techniques, the artificial intelligence techniques also, to see that how an HVAC can be monitored to the Internet of Things, and then how the temperature can be controlled, how the CO2 levels within the room, how it can be seen, and then how the temperature can be manipulated. All those things are being happening in a subtle way. But yes, before going to that, we should use these technologies in place, and then we should go for that. And that's not far off. Like, it should happen at any time.
Thank you very much, sir, for a wonderful session. Thank you.
Mr. Veeramani has got a question. He's raised his hand. Mr. Veeramani, please.
Yes, I am Veeramani. Good evening, Mr. Murali and Venkat. I am Veeramani from Sanma speaking. You have given the nice speech with so many examples, very good. And I have one more doubt. Is there any standard procedures or format to do? We are having we are doing the practicing of energy saving meeting and everything. We are weekly doing. Just before 1 hour also, we conduct the same with our colleague Srinivasan and other team members. And I am having, is there any standard procedure or format for doing this for better performance, or ISO 15001 alone will give the best performance for?
Yes. See, to answer your question in three different ways. ISO 15001 is a big standard. It's a framework.
It's a huge standard, yes, sir.
So it can be applicable for a foundries to textiles to whatever industry it is, like even a service industry also for that matter.
Okay.
But what we have to basically understand is, as I was mentioning a few minutes back, what are the significant energy use that you have to identify in first place? Like if you are from foundry, am I right? It's the foundry division is yours.
Yes,
sorry?
Foundry and machine shop.
Yeah, foundry and machine shop. If you're looking at the foundry, how many instances after the liquid metal has been taken in the induction furnace, you need to wait for the pattern shop people have not given the patterns at the right time. The mold is not getting closed at the right time, where the mold the drying has been happening in the last minute, and as a result of which you have to idle that liquid metal inside your furnace for a long time. That one is the energy part of it. They may keep it at a very low frequency, that they may say that they will justify it that way. But on the other hand, like the liquid metal also will take about a lot of moisture or a lot of ingress of air it takes, and then it will lead to another problem also for that matter if you keep it for a long time. And again, you may have to rework another thing. Again, the energy part of it is being utilized unnecessarily. So that synchronization of the activities, like right from the melt to the tapping and then teaming into the mold, how it can be synchronized so that there is no wait time at all for that matter. So likewise, you can look for on a day-to-day. In fact, the foundries have got many stories to say on a day-to-day basis, if you agree with me. Like, and if that has been fine-tuned, slowly, and then looking at it, and when you sensitize the people in the shop floor, I would say that then everything will fall in place. That's what my thought process is.
Okay, what you are stating is from the past of what is the current process we have to improve. That is the process of time study basis you are telling. What I am asking is differently. Is there any, as you said earlier, restoration and reduction and reuse and elimination? There are so many factors. This is one of the reduction of energy in our plant. But we cannot totally eliminate it. But reduction also, it is the conservation of energy only, I agree. For that only, I am telling that, is there any standard procedure? These are the procedures to do, just like I am asking.
To tell you, there is no prescribed format is not available.
Oh, okay, no problem. Thank you. Thank you. Thanks, Mr. Vengat.
Yes, thank you.
Thank you. Thanks, Mr.
Thank you, Mr. Veeramani. I now request Mr. B. Srinivasan, who's raised his hand.
Yes.
Mr. B.
Sir,
Srinivasan,
very good
please.
evening. Sir, very good evening, sir.
Good evening.
Yeah, as usual, last 4 years back, we got that service through LRQA, and you and another 3 team member have audited. And in the year of 2016-17, we had the audit and continuous tracking of that consumption. Even after you completed that energy study, you were follow up with me. And now I can say that in the year of 2019-20 and 2021, we are continuously achieving the norms, sir. Whatever we fixed according to the liquid metal as well as cause, we are really thankful for the audit which LRQA taken through in our factory in the year of 16-17, and form the team. Actually, as you rightly said, that the approach is the main key. That approach now completely, we set that whatever you given the guideline, and you have educated the entire team. The spirit has complete, top to bottom. Even in the leadership team to bottom level person. Now the complete awareness came in that approach. So instead going correction of the equipment or other investing more money in that like VFD or other things, we invest the people knowledge and skills, and we implement a lot of interlock as you guided, and we implemented thermography study and all. Now we brought it in control. So I actually I'm very much eager to share with you that we are achieved that norms. So, and we got appreciation from our management also. That we are very much thankful to LRQA that the approach now set across the SMML and VML campus, sir. So very grateful. And today also that session is very elaborative and very knowledge, giving much insight to the approach. So again, once again, you are very clearly and strongly you have educated all of us to have the systematic approach. That once again, thankful to you for the today's session also. Thank you very much, sir. Thank you so much.
Many thanks. Thank you for that.
Thanks, Mr. Srinivasan. Members, any other questions to pose to Mr. Venkat? And by the way, Mr. Venkat is a lead auditor for ISO 1445000 and 22000 and other management systems. And he's a vivid cricket player. Has represented Mangalore University while pursuing his engineering from National Institute of Technology. And he's also represented his college during his college days. Yes.
Can I have
anybody to ask?
Venkat?
Yeah, please.
A question to Mr. Venkat.
Please
go ahead.
I'm Satish Menon, Head Engineering, Tata Coffee Limited. So while it was very interesting. Am I audible?
Yeah, you're quite audible.
Yes, audible.
See, I particularly like the fact that you spoke in your presentation was very lucid, very clear, very crystal clear, and it's of utmost relevance to us in the plantation beverages sector. Tea, coffee plantations, which is now reading under energy crisis and beating and finding it an insurmountable challenge as to meet the spiraling cost of production. And in your consumption sector-wise chart also, you have mentioned about 18% of this is in agriculture. It will be probably enlightening for you to know that in a conventional tea factory, or especially if we talk about tea factory, about 65 to 70% of the total cost of production is only by way of energy. Basically only in terms of the thermal faculty as well as the electrical. And one thing what you should realize is, I think there's a lot of scope for really vastly opening up this sector, because plantations are really you have very little incidence of actual power, because it will be shocking for you to know that the grid is to DG ratio, especially in Kodagu where I am, is as high as probably 70 is to 30. You have only about 70% of grid, and you have 30% of is by standby DG. And when you have things like this, and especially with respect to Mr. Venkat, when you talked about when we're trying our best in Tata Coffee Limited, to conserve energy, when you did bring out the point of VFDs, although thankfully SESCOM has not introduced a sort of a harmonics penalty, what I would like to know from you, supposing I have a particular application where it's a fixed RPM constant torque motor, when I put a VFD, and when I derate my voltage and starting torque, voltage by about 58% and torque by about 33%, supposing it is less than the starting torque required by the motor, in such a case, would a VFD be suitable or effective? Because I have a particular application of a 100 HP 6-pole motor running at 1000 RPM. Actually, the motor RPM is 993, as you can see, with very less slip. But I am reduced it by using a belt drive on pulleys to 408. So now in this case, supposing I have got to put a VFD, I would have to reduce the frequency to about 21 from the present 50. But what I have not ventured to do it is because, like you said, suppose we go about doing that and have various other ramifications. I know it's a fixed RPM constant torque motor. So suppose I do my derating of torque, and supposing the starting torque is more, how will the application run?
Yeah, that's a good question. You started with the consumption in that sector of the agriculture part of it, and you nicely came down to your operational difficulty. Yes, in that sector. Now, have you ever identified what is the no load current does it take? Have you ever studied it? Like, because see, all these motors, I mean, efficiency, any motor efficiency for that matter, if it is 85% is a good number. You know, NEMA, B motors, like, you know, what is NEMA? NEMA stands for National Electric Manufacturers Association, has classified motors, this is what it is. And any motor which performs much better than the NEMA B category, whatever it is, it's an efficient motor. That's what it is. In the recent past, which you have seen in the news magazines, if you have seen that ABB has come out with a what you call motor, which gives 98.8%, and now it gives 0.25% extra also. What is the efficiency of the motor? It is like in terms of its mechanical output divided by the electrical input what you are giving into 100. That's what it is. In your case, have you ever studied in first place what is the no load current does it take? When it is a no load current, this is what it is more than 50 or 60% higher than the rated or the labeled or the one which is the rated load which is given in your motor. Then you should look in for, should have to go in for a VFD or whatever it is like. But without the data in place, it's difficult to conclude at this point in time whether you can go for a prescriptive solution or you have to go for a VFD straight away. That's point number one. Point number two is, like, if the sizing of the motor is very high, and instead of you investing in various other things, I didn't hear the kilowatt motors of the power rating, I did not hear from you. Like, if it is going to be there, can you resize the motor and then make it about to the requirement? If the initial torque values and other things are going to be high, and if you can see about the heat part of it also for that sake, it is going to take. If those studies are made and then you come to a conclusion, then it is every possibility is there that if you can go for a VFD and then you can what do you call mitigate the power consumption at the moment, whatever it is. But you have to do these studies in first place. What is the temperature rise? Does it come through? Yeah. Above the ambient, does it increase more than 30 degrees centigrade? Point number one. Secondly, you have to also study the no load current is how much by putting a clamp meter and then check momentarily you can check, or putting a digital analyzer for a long period of time for 1 hour or 1.5 hours for various batch sizes depending on the various loads which are doing. I do not know this is used for a drying purpose or whatever it is. Like, no, depending on that, the batch loads you have to verify. Then you have to collect the data and then come and arrive at a situation. So straight away, I will not be able to talk about that you have to change or you can go in for a VFD. I should not prescribe or I should not advise you wrongly. I'm very cautious in my statement.
Thanks, Vinod. I'll do just that.
Thank you.
Thanks very much, Mr. Venkat. We have with us, if there are no other questions, I now request Mr. Ramesh Saligrama to propose a vote of thanks. Mr. Ramesh Saligrama is the chairman of BCIC's Energy Infrastructure Expert Committee. He is the vice president of Bosch Limited. Over to you, Mr. Ramesh.
Yeah, thank you, Murali-san. First of all, I think it was a wonderful session, Mr. Gurumurthy. I think I was just seeing the time, but of course, you started well, and I think the sequencing of it was like a story. It started with the planning and it ended up with the audits and other things. I think it was a perfect session today. And as you rightly started, it is very apt at this point of time. Each one of us, of course, on one side, we are talking about energy shortage or the energy cost being high. On the contrary, that we need to see that how do we improve our efficiency, effectiveness, of course. All this amounts to adding to the value of the product that each one of us are looking at. And very aptly, you guided us to say that, yeah, it is not bottom up, it is top down as far as energy is concerned. And I would second it. Without the top management commitment, nothing can happen. Not only energy, but all others. But in case of energy, the management support is very much needed because of technological changes that we need in order to realize the improvements and the efficiency that we are looking at. More aptly, you touched upon the current trend. Digitization is something which is a must. And with this, the transparency increases. And you rightly said that what gets measured gets reviewed. That means with this digitization, it helps not only the operating colleagues, but also the management. That what I'm investing for and what I'm going to get it. And which I also looked at. Somebody questioned whether is there going to be a mandate in future, whether it could be a direct mandate or an indirect mandate. But I am already seeing that. I think most of us are working for now ESG reporting. Indirectly, it looks for each one to post themselves that how efficient I am going to be, and it is going to add not from the energy point of view, but it is going to be to all our stakeholders where our positioning would be. So it indirectly mandates to each one of us how efficient I can be in this ESG sector too. So first of all, once again, I thank you, Mr. Gurumurthy, and it was an apt topic, and I am no doubt that each one of us will go back, and I think the prescription you said in that when I finished this today's webinar, what did I learn? I think quite a bit we have learned in the session today, and each one of us can enable one or the other. And I would say that, yeah, in case of any doubts, maybe we may reach back to you. I think you already displayed your details and the email and the telephone numbers. Probably one of us could disturb you for either clarification or guidance to move forward. So, not the least, Murli-san, thank you for organizing from the BAI side, and it was a very topic which was needed. And I would thank all the participants for patiently staying for almost 1.5 hours. Normally, we don't have such long webinars. I think this is one specific thing, and it was interesting. And each one of the participants who joined stayed till the end. And I appreciate all the participants for this fruitful session. Once again, nice evening to all, and special thanks to Mr. Gurumurthy and Mr. Murali. Thank you.
Yeah.
Thanks very much, Ramesh-san, and Mr. Venkat. Over to you, Rupa.
Thank you very much, sir, for your exhaustive and insightful presentation. And as a token of our appreciation and acknowledgement, we would like to play a small video bit of our of the thanking message from the chamber. We'll be sharing the memento to your address shortly, sir.
Thank you for that. Thank you.
Thank you very much.
Thank you very much.
Have a nice evening.
Thank you, BID Industry Association, and thank you, Mr. Ramesh Saligrama, sir, for joining for this session. And I also
Thank
thank
you.
all the participants for their participation at the session, sir.
Thank you, Ram.
Thank you.
Thank you, Ram.
Thank you.
Thanks.
Have a nice evening.
Thank you.
Have a nice day.
Thank you so much, sir.
Thank you all.
Thank you.
Thank you, sir.
Thank you.